Hey PoA, let's take a look at this homework 1.4. I will say today was probably one of the best days we had in PoA, so I appreciate that. And if you're watching this video, appreciate that too. So let's jump into the homework. So here we have timeless toys, builds tricycles and wagons. And this owner noticed that there are several different ways that a customer could place an order for 5 items. For example, the customer could order all tricycles or all wagons or some combinations of both. So we have to attack this problem, and if there's one thing we kind of picked up today, hopefully, is that the best way to attack a problem with this many kind of numbers floating around isn't just to kind of randomly guess and check, but is indeed to maybe attack it using an organized chart or table, or at least a visual pattern. And I'm going to kind of maybe tend towards the organized chart and table. That's just because that's the way I think. And certainly, if you think differently, that's cool. So I invite you to go ahead and make a diagram if that's what suits you best. All right, so let's jump into this. So we have to kind of tear apart this problem first, because there's some really important information that you have to kind of pick up. And the first thing I'm going to draw your attention to is that this is a 5-item order. That gives us one limit or constraint that we have to meet in this problem. Also, if you didn't kind of pick up on the reading, that we're dealing with tricycles and wagons, and that kind of implies you know something about those things. Tricycles, in this case, have 3 wheels, and wagons have 4. At least the wagons I'm aware of. Maybe you know some kind of crazy wagon that I just don't know about. All right, so let's set up our organized list. I'm going to zoom in a little bit to give myself a little bit more room. And again, we have to keep in mind that we're dealing with a 5-item order. So let's label this, and I don't want to write tricycles and wagons over and over again, so I'm going to label this T, and then I'm going to label this W. And then in the next column, I'm going to go ahead and put this total. Okay, and I'm going to zoom out just to make sure that I'm reading the right things. We have to list the number of wheels that would be needed. Okay, so that means we have to add a little bit more to our table. I'm going to leave my space a little bit of space for the work or the process, and then in this case I'm going to put the wheels. Okay, and I'm sorry for my mess of handwriting. This is going to happen. All right. Now from here, and I think it was Marquise, maybe a few others that kind of picked up that in this ordered pattern, you should probably go ahead and start with like an extreme. So I know that the total is going to have to be 5. So the most extreme way I can do that is to order no tricycles and say like 5 wagons. Well, if I order 5 wagons to meet my 5 total, those 5 wagons each have 4 wheels each, which would be a total of 20 wheels. Now, that we're not asked to find a total number of wheels, so we just really have to list all the combinations. So to attack this systematically, what I'm going to do is just simply drop a wagon. Like if I take my wagons to 4, but I still need a total of 5, that means we'll have to add a trike. Now that changes my work a bit. If I have 1 trike with 3 wheels, and then I have 4 wagons, each with 4 wheels, okay, we have 1 times 3 makes 3, 4 times 4 makes 16, add those together, that's a total of 19 wheels. Okay? And this is like the work column, again, kind of as Mr. Bostic was saying today. If you don't kind of pre-order and pre-make your whole table, you leave yourselves plenty of room for that work. All right? So let's continue, because we have to write all the combinations. So if we drop another wagon, that means we have to add another trike to make our 5 total. Let's take a look at this work. Okay. 2 trikes at 3 wheels each, and then 3 wagons at 4 wheels each. 2 times 3 will give me a 6. 3 times 4 will give me a 12, which will give me a grand total of 6 plus 12, or 18 wheels. Now here's where picking up on patterns might really be to our benefit, because at this point I'm noticing a few things. And I'm going to change my color to try to help you see what I'm seeing. Right here, I went from 5 to 4 to 3, and this one from 0 to 1 to 2. So I can probably guess that this is going to be 3 and 2 just based on the pattern I've already established. And again, 3 plus 2 does make our 5 total. I'm going to skip over the work, and I'm going to have you guys notice this pattern in the wheels. Check this out, 20, 19, 18. So I can guess with pretty good confidence that that wheel total will be 17. Now we can check this, of course. 3 trikes at 3 wheels, and 2 wagons at 4 wheels. Well, that'll give me 9, and that'll give me 8. 8 plus 9 is 17, so we're in business. This pattern is going to be okay. So I don't have to really, if I can take a second and notice some good patterns, I don't have to do so much work, so to speak. So let's continue this pattern. That should be 1 and 4, and that should be 16. Okay, and then 0 and 5, which is the other extreme if I just order only trikes. And then that should be 15. And again, 5 times 3 should be that 15. So again, you can cut down the amount of work that you have to do for any given problem if, one, you stay organized, and 2, you notice patterns. So that definitely gives me a reason why I want to pay close attention to this order list. Let's attack question 2. If a customer ordered 5 items and had a total of 17 wheels, how many wagons did they order? Now, here's the other thing about making an organized list. Answers further down the line become much easier. Check this out. 5 items, 17 wheels. Here's 17, 5 items. So the number of wagons they ordered should just be 2. And the evidence is a table itself. So again, more work initially, keep myself organized, gives me a lot faster ways to answer problems later. All right, so in solving a problem like the one above, what are some of the steps we take? Think through your process and list the steps you take. I'm not going to make a list, but I will kind of go back and tell you about my organization and have you guys reflect upon that. If you kind of rewind the video and want to take another look at it, the first thing I did is set up all the things I need to track. And there were a lot. I had to track the total number of trikes, wagons, the total number of items. I had to leave a space for myself to actually do the processing work, and then the wheels at the end. So the real big part about this was keep myself organized and tracking all the work that I needed to or all the items I needed to track to do the work. Okay, so I'm not going to write that, but certainly you can. Again, I'm not going to. There's no real thing I can show you for this next problem. It's really just your thinking and thinking about this unit. And again, I want to reemphasize that today was probably the best day we had. So certainly there's a lot to talk about. What I ask you is maybe specifically to think about is just think about how we have changed your seating and spread you guys out. Why we've done that, why we're kind of having you guys take a careful look at your own problem solving and others. All right, so let's move on. Oh, there we go. I love these. These are like the greatest. These shape puzzles. Let's take a look. And you guys have done a great job figuring out this is really about where to start. If you look at this whole puzzle, finding a nice entry point is really going to be the difference between doing this successfully and not. Now, this one in particular is a little bit strange because you don't have any one equation that only has, say, one unknown. So here's one where you have to maybe look at a couple in combination. And the couple I'd have you look in combination is number 1 and number 2. And for the reason, I had this idea that if I take a triangle and a square, even if I don't know what they are, it makes a total of 8. And if you look at equation 1, I do have a triangle and a square together. So this triangle and square, according to the second equation, should be exchangeable for an 8. Okay? So 2 items equal 8 according to equation 2. That's a replacement. We call that a substitution into equation 1. So it's completely replaceable. Okay. Now this does give me a nice equation to start, because now I just have circle plus 8 makes 13. Well, if I take circle plus 8 equals 13, a number, I don't know, plus 8 equals 13, that tells me that circle has to equal 5. Okay, well, if that circle is 5, well, then that circle has to equal 5 as well. Well, now I have 5 plus a triangle equals 7. Triangle must be 2. And now if I go back and look at my original, triangle plus square equals 8. Based on my work so far, I know the triangle is 2. So 2 plus a number is 8. That number has to be 6. Okay? These are getting tougher, fair. But again, you do have a strategy to attack them. It's all about finding the commonalities and entry point. All right, let's look at number 2. All right. 9 tricks. I love these. So find the sum of the digits for each multiple of 9 below. So the digits, of course, when you're looking at a number like 18, the digits, there's 2 of them here. One is the 1, one is the 8. We want to find the sum, which that means add. So this will be 27. So let's look at 2 plus 7. That would be 3 plus 6, 4 plus 5, yada, yada, yada. Okay. So if I add all these up, look at that crazy pattern. Now this is something I think maybe some of you guys already knew, that if I take any number times 9 and then add the resulting digits, you always end up with 9. Smiley face. All right. The number 5. After selling tickets to a dance for $325 each, the student council brought in $1,020.50 from ticket sales. How many tickets did the student council sell? Well, you have to kind of think maybe about a model problem to understand the thinking in this one. So let's forget about this problem for just a moment, and let's just think about a simpler situation. Let's say I was selling tickets, and those tickets were like $2 each. if I sold 10 tickets, well, how much money would I have gotten? So if you think about that process, that becomes a multiplication problem. 10 tickets times $2 each equals 20. Now, in terms of kind of thinking about this newer problem, the information is a little bit different. So again, if we look at our model problem, this was number of tickets. This guy right here represented the cost, and that was multiplied, and that equaled money. So if I look at the problem I was given, I'm given kind of some weird pieces. I'm given the price, which was $3.25, so I can put that in for the cost. I was given the total amount. Oh, put out of space. Okay, when the thing I don't know is the number of tickets, so this becomes an exercise in adding, in kind of solving for an unknown. I know you did a little bit of this in 8th grade. It's probably been a while since you have, though. Okay. But you had to kind of think in terms of undoing an operation. So if I have this thing I don't know times 3.25, well, the opposite of multiplication is division. So if I take 10, 20 divided by, 0.5, and divide that by 3.25, okay, I can see that the number of tickets is going to equal 314. Okay, and that's something that if you're looking at that and saying, wow, Mr. Collins, I don't really remember that, give us some time. This is something we'll address both in class and through the homework. We have a chance to review that concept. Okay. And let's finally move on to number 6. Angela and Tina are at the beach. How long a piece of rope do the girls need to totally enclose their space? So a couple of things I've noticed right off the bat is the shape of what you're dealing with. Okay, and the shape of what you're dealing with looks like a rectangle, which is a very common thing. So let's think about what you know about rectangles. Well, if I have one side of the left-hand side of the rectangle to be 3.5 yards, that means this has to be 3.5 yards as well. And the top is 4 2/3 yards. And so is the bottom. So this becomes an issue of adding. So if I write this addition problem out, okay, I have 3.5 plus 4 2/3 plus 4 2/3 plus 3.5. So let's talk about adding fractions. I know sometimes fractions scare people, but they shouldn't. They can't hurt you. Let's first add all the whole pieces together. So 4 plus 3 plus 4 plus 3. 4 plus 3 makes 7. 4 plus 3 makes another 7. So together that makes a 14 for the whole pieces. I'm going to switch colors for you. Here's a half and here's a half. So together that will make one whole. If I take 1 1/3 away from the 2/3, that will give me another whole and leave me with a third at the end. So we can kind of take these fractions and decompose them into pieces, and that's a strategy for adding them pretty quickly. Okay? So let's finish this up. 14 plus 1 should be 16, and then that just leaves the third, which we'll bring down. So I need 16 1/3 pieces to complete this. So, okay, so thank you guys for watching this. I hope it helped. Again, we had a good day today in PoA. It's the best day we had so far, so please keep up that good work. You guys have a good weekend. We'll see you on Monday. Thank you guys for watching this. Oops.